Non-Parametric Tests, which are
the Mann-Whitney test,
the Wilcoxon Science Ranks Test,
and the sign test.
But before that, let us introduce ourselves first. My name is Fatia Ramadhani and my student ID number is 081.
My name is Joshua Manuel Sinariko and my student ID number is 094.
My name is Rizky Putra and my student ID number is 065.
Without any further ado, let's start.
Now we are going to learn about the Mann-Whitney U-test, which is an useful non-parametric statistical test, especially when we can't use the regular t-test. But before that, let's first understand what non-parametric are. According to Petrus, 2019, non-parametric statistical tests are generally less powerful than parametric tests and are also less likely to mislead investigators because they are not dependent upon certain restrictive measurement and distributional assumptions. Non-parametric procedures are sometimes an effective way of dealing with non-normal or unknown distributions, but are not always the answer to unequal variances. Non-parametric procedures are also well suited to small sample sizes, and rank tests are particularly helpful when outliers are present in a data set, since ranks of raw scores are not affected by extreme values. So when do we use the Mann-Whitney U-test? This test is used when we want to compare two independent groups but certain assumptions of the t-test are not met. For example, when data is not normally distributed, or when sample sizes are small, or when data is measured at the ordinal level. It's a non-parametric test, which means it doesn't require our data to follow a normal distribution. Instead, it works by ranking the data. Like most tests, we start with two hypotheses. The first one is H0 or null hypothesis, which means there is no significant difference between the two sets of data. The second one is H1 or alternative hypothesis, which means there is a significant difference between them. Here's how it works, step by step. The first one is combine all the scores from both groups. The second step is rank the scores from lowest to highest. If there are ties, assign the average rank. The third step is calculate the U value using this formula. After we get the value of the U, pick the smaller U value between U1 and U2. That's the one we'll compare to the critical value. Let's look at an example. The question is, two groups of students are asked to grade the text they have read on a scale of coherence from 0, which means totally incoherent, to 10, which means totally coherent. The researcher wishes to know whether there's any significant difference between the two sets of ratings at the 5% level in a non-directional test. After ranking and doing the calculation using the formula, we find U1 is 61, U2 is 11. We are going to use U2 since it has a smaller value. At the significance level, 0.05 in two-tailed testing for N1, which is 8, and N2, which is 9, the critical value of U is 15. Since 11 lower than 15, so we reject the null hypothesis and accept the alternative hypothesis. Another extra information is that if the samples are large, over 20, we need to use the Z value instead of critical U. If the Z value is greater than or equal to the critical value, for example, 1.96 at 5% significance, then H0 is rejected. Now we are going to use SPSS to perform the Mann-Whitney test with the same question as before. The first step is set your data to ordinal or interval, define the groups, and then go to Analyze, Non-Parametric Tests, Legacy Dialogues, to Independent Samples. Choose Mann-Whitney U as the test type, then run the test. After doing those steps, we will get the result like this. In determining whether there is a significant difference between the two sets of ratings or not, we can look if U obtained is less than the U table, or if the p-value is less than 0.05, then we can reject H0. On this occasion, I want to choose using p-value in determining whether we accept or reject the H0. So, since the p-value of z-test is 0.014 is lower than 0.05, H0 is rejected and H1 is accepted.
The Wilcoxon-Saint ranks test. The Wilcoxon-Saint ranks test is a non-parametric alternative to the paired samples t-test. It is used when we want to compare two related samples, such as scores from the same subject before and after treatment or matched pairs. H0. Null hypothesis. There is no significant difference between the two datasets. H1. Alternative hypothesis. There is a significant difference between the two datasets. Steps to calculate the Wilcoxon-Saint ranks test. First, calculate the differences between each pair of scores by subtracting one from the other. For example, B minus A or A minus B, and record the sign. Second, rank the absolute values of these differences, ignoring the signs. Third, ignore pairs with a difference of 0. If a pair's difference is 0, it is not included in the test. Fourth, assign ranks. If two or more differences have the same value, assign the average of their rank position, that is, pi ranks. Fifth, assign the original signs back to the ranks. Sixth, calculate the sum of positive ranks and the sum of negative ranks. 7. The test statistic W is the smaller of the two sums, positive or negative. The value of W must be smaller than or equal to the critical value if the null hypothesis is to be rejected. Remember, when deciding on the critical value, use the number of non-zero differences as n. Tied pairs with a 0 difference are excluded from the count. Example calculation. A group of 10 students translated 2 English passages into French. The number of translation errors made by each student in passage A and passage B is recorded. Here's step-by-step analysis. Student 3 had a difference of 0, so this pair is ignored. That leaves us with n equals 9. Now calculate sum of positive ranks, positive 2 plus positive 4.5 equals 6.5. Sum of negative ranks, all other ranks, equals 38.5. W equals the smaller value, which is 6.5. Compare W to the critical value. For n equals 9 and alpha equals 0.05 to test, the critical value from the Wilcoxon table is 5. Then the decision, since 6.5 is greater than 5, we cannot reject the null hypothesis. There is no significant difference between the two datasets. Z-score and SPSS output. If the number of pairs is greater than 20, a z-score can be calculated using this formula. Example calculation. Suppose W equals 209 and N equals 35. Plug into the formula. The sign of Z is usually ignored in decision making. The critical values for Z at 5% significance level plus or minus 1.96 for a two-tailed test, plus or minus 1.64 for a one-tailed test. So, if Z is greater than plus or minus 1.96 two-tailed, we reject the null hypothesis. SPSS output interpretation. Negative ranks equals 7, positive ranks equals 2, ties equals 1, total equals 10, W equals 6.5, Z equals negative 1.921, p-value equals 0.05. Since p equals 0.05 is greater than 0.05, we cannot reject the null hypothesis. Since W equals 6.5 is greater than the critical value of 5, we cannot reject H naught. Then there is no significant difference between the two datasets according to both the manual calculation and SPSS output.
In many research cases, especially in linguistic or social sciences, in data collected is in the form of ranking or ratings. For example, we may ask informants to rate two different sentences on a scale of acceptability or politeness. However, since these are ordinal data, we cannot assume equal intervals between the points. This makes it difficult to use statistical tests that require interval or ratio scale. While we can use the exact magnitude of the differences, we can observe the direction of the differences, whether one sentence is rather higher than the other. The sentence focuses exactly on that. It, it ignores the size of the difference and only looks at the direction. Now, let's move on the hypothesis used in the sign test. The null hypothesis, or H naught, states that there is no significant difference between the two datasets. The alternative hypothesis, or H1, states that there is a significant differences. To perform the sign test, we follow these steps. First, we calculate the difference between each pair of scores, always subtracting in the same direction. Then we record the sign of the difference, either positive, negative, or zero for ties. Tied scores are removed from the analysis and we update the number of valid pairs accordingly. Then we count the number of pairs with the less frequent sign. This is our value of x. Finally, we compare the value of x to a critical value. If x is smaller than or equal to the critical value, we reject the null hypothesis. Let's look at an example. A group of participants were asked to rate a sentence on a scale from 0 to 5. They read it from both formal spoken English and formal written English. The researcher predicted that the sentence would be read as more acceptable in formal spoken English. After collecting the data from 15 participants, the results show 10 positive differences, 3 negative differences, and 2 ties. the tithe value are removed, so the total number of pair become 13. Here the less frequent sign the negative difference, which occurs 3 times. So x equal 3 and n equal 13. At a significance level of 0.05 in a directional test, the critical value for n equal 13 is 3. Since x equal the critical value, the null hypothesis is rejected, and we conclude that there is a significant difference between the two data, datasets. However, if we use a non-directional test, the critical value becomes 2. In that case, because x equal 3 is greater than 2, we return the null hypothesis. So whether we reject or return H naught depends on whether the test is directional or not. If the number of observation is greater than 25, we conclude Z value instead using a special formula. For example, if we have 100 non-type pairs and 42 of them are positive, x would be 42. Plug in the number into the formula gives us a z value of 1.15. This z value is below the critical value for 5% significance. So the null hypothesis is written, and we conclude that there is no significant difference between the two datasets. Now, let's briefly discuss how to use SPSS to perform the sign test. In SPSS, you should set the variable measure to interval or ordinal and go to analyze and non-parametric tests like a dialog and two related samples. And last, then check sign as the test type. The SPSS output in this case confirm the same results. There are 3 negative differences, 10 positive differences, and 2 ties. The p-value to tail is 0.092, which is greater than 0.05. So again, we retain the null hypothesis in a non-directional test. Lastly, a simple decision flowchart helps you decide which test to use. If the sample are independent, use the Mann-Whitney U test. If the sample are related and the data is at least at the interval level, use the Will-Jackson sign rank test. And last, if the data is only ordinal, then use the sign test. Thank you.
We think that's all for today's video discussion. We hope you all can understand the material better after watching this video. Thank you very much for your attention and goodbye.